Hey everybody, it's time for section 5.2, ways to prove that a quadrilateral is indeed a parallelogram. Let me quickly apologize, I'm wearing this big gaudy scarf because it is big cold and I'm trying to stay warm. It's been hard, but we'll persevere. All right, just like when we're dealing with triangles, there are ways to know that we have congruent triangles with side, 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 angle, etc. There are 5 ways of knowing that a quadrilateral is indeed a parallelogram. So this is all about knowing, proving that you have a parallelogram. The first way, well, if both pairs of opposite sides are parallel, then you have a parallelogram. That's the definition of a parallelogram. So if you know that both pairs of opposite sides are parallel, you definitely have a parallelogram. If you remember from the characteristics from section 5.1, what's going to follow this will sound very familiar to you. If both pairs of opposite sides are not parallel but congruent, okay, then you know you have a parallelogram. So we're basically turning around and using those properties that we learned about in the previous section. Here's where it gets a little bit different. If one pair of opposite sides are both parallel and congruent, then you have a parallelogram. So you don't have to have both pairs are parallel, both pairs are congruent. If one pair of sides is parallel and congruent, then it is a parallelogram. And it doesn't matter which pair. So it can be these opposite sides, or assuming this is the same parallelogram, these being congruent and parallel. Either way, you know for sure that this is a parallelogram. And then, of course, if this is indeed a parallelogram, then these other opposite sides are both congruent and parallel as well. It takes on all of those properties. But we're talking about how can you know for sure that you have a parallelogram or not. And to be clear about this is not a parallelogram. If you have this parallelogram, and if one pair of opposite sides is congruent and the other pair is parallel, that does not tell you that you have a parallelogram. It has to be the same set of sides that's both parallel and congruent. Okay, fourth reason, if both pairs of opposite angles are congruent, so we have if both sides are congruent or angles are congruent, then you indeed have a parallelogram. And finally, the last one here, the fifth one, if diagonals bisect each other in a quadrilateral, then it has to be a parallelogram. So these are most of the properties that we talked about. The one that's missing is the one about consecutive angles being supplementary. That does not tell us anything about it being a parallelogram. Okay, so the first set of questions that you'll be answering is, given this diagram and the information that goes with it, do we have a parallelogram or not? So let's look at example A. Oh, I'm sorry, I got ahead of myself. If the diagonals bisect each other, that means that the intersections are a midpoint for each of them. That's just another way of saying that, which I wanted to throw that in there. All right, back to our example. In example A, we have these angles are congruent, and then these angles are congruent. It matters where they are. These here are alternate interior angles. What does it mean if we have alternate interior angles? It means that we have parallel lines, if we have alternate interior angles that are congruent. So if angle DAC and ACB are congruent, then sides AD and BC have to be parallel. Likewise, if these angles are congruent, then we have to have a parallel line, transversal, parallel line. We have parallel lines there. So now we've established that both pairs of opposite sides are parallel, so yes, we absolutely have a parallelogram. Okay, question B. Here we have a pair of opposite sides that is congruent, and we have a midpoint to a diagonal. Which one of these reasons up here involves a single pair of opposite sides? We have one pair of opposite sides is both parallel and congruent. Nope, we don't have both parallel and congruent. A single diagonal is bisected. Nope. We don't have a parallelogram there. We need more information for that. If we knew that this other diagonal was bisected as well, or if we knew that these sides were parallel as well, or we knew that segment PS was congruent with segment QR, then we would know, but we don't know any of those things. Let's look at example C. Here we have one pair of opposite sides that are definitely congruent. That's a good start. We don't have this angle. How can we find it? That's right, the sum of every quadrilateral is equal to 360 degrees. Using a little bit of subtraction, we figure out that this missing angle is equal to 75 degrees. Oh, look at there. Both pairs of opposite sides are congruent. I'm sorry, of opposite angles are congruent. So yes, we absolutely have a parallelogram. All right, go ahead and pause your video, and I want you to answer these 6 questions on your own. I'll come back and give you some answers and a couple of insights in just a second. Pause. Now. Did you see these same side interior angles that were supplementary right there? 75 plus 105 equals 180. You needed to in order to say that we have, yes, we have one side, one set of sides that is both parallel and congruent. Here are these other answers. Please circle, mark, be ready to ask questions if you have them. Come see me. I'd be glad to help you as well. All right, the next set of questions that you'll be answering says, what must x or y or whatever variable be in order to have a parallelogram? So for this to be a parallelogram, we're going to have to show these are the lengths of these diagonals in here. And if this is indeed a parallelogram, then these diagonals have to bisect each other, which means that 3x has to equal 2x plus 5, and then 5y plus 3 has to equal 3y plus 15. So we create these equations and we'll solve. X has to equal 5, y has to equal 6. It would be in your best interest to plug these things back in. So if x equals 5, 3 times 5 is 15, 10 plus 5 is 15. Yes, those have to be congruent, and then the same thing here. This has to be, 3 times 6 is 30, plus 3 is 33, 18 plus, that wasn't very good math, was it? Oh, I don't know what I was just doing. This is 33. 3 times 6 is 18, plus 15 is 33. So 33, 33. Yeah, we're good. On the next example, in order for this to be a parallelogram, these opposite sides have to be congruent. So set those things equal to each other. I got one equation that has one variable. I have another equation that has 2 variables. Solve that one first. If you had a system of equations, we'd have to use substitution or something else. Once we know that x is equal to 2, plug it in so that we can figure out what y is. Y ends up equaling 3. I'm going to plug these things in to make sure. This would be 6 times 2 is 12, plus 3 is 15. Excellent. This would be 4 times 2, 8, minus 6 is 2. Yes, everything checks out beautifully. All right, when you flip the page, these next 9 questions end up being the same idea, just taken from different sources. If you're paying attention, and I'm sure that you are, I would like for you to do 6 of these 9. You can choose your 6, but I'd like for you to do 6 of these 9. If you're not paying attention, do all of them. If you really want to do all of them, just tell me I really want to do all of them and write that right up in here or something like that. Here come some answers. I hope if you haven't paused already, do so. Did you get some gasp decimals and fractions in there? That can be okay. This last set of 9 questions are kind of like the ones that were on the front, just with some real basic information that's given. I'd like for you to try to answer all 9 of these here on your own. Here's 7, 8, 9. Number 10, only one, well, you have one pair that's parallel, the other is congruent. No good. Number 11, yes, 2 pairs end up being parallel. Those we have alternate interior angles that make both pairs that are congruent. Number 12, yes, one pair is both parallel and congruent. Number 13, yes, they're both parallel, both sets are parallel. Number 14, no. Take a look at this guy. For these are not alternate interior angles that are congruent right here. Even if it was that, these two angles here would make, if it was this and this here, the only angles that are involved here would be line, transversal line. We would be showing that just this side's parallel, have nothing to do with this anyway. But these are not congruent alternate angles as well. So, no, they're not. And number 15, nope, not. Anyway, hope that made some sense. And, well, before you take quizzes and stuff like this, you need to be well rested. Get some rest and stay warm. Bye.